Light hits the solar panel and the propeller starts spinning. Light goes off and the propeller stops. It's a simple example of the power of solar, but a demonstration like this was life-changing for Professor Anita Ho-Baillie. She was an undergraduate student at the time and saw a water pump being powered in a similar way.
So I was absolutely amazed because I was looking for a PowerPoint and there was none.
She'd been interested in pursuing either computer science or electrical engineering, but from that day on, she knew that solar would be her focus. While doing her PhD, Professor Ho-Baillie traveled to Nepal, where she co-supervised a group of students installing a solar battery system powering a remote medical clinic. She was there when a local woman went into labor.
So you can see that it's so important for that medical clinic to have access to electricity, to have access to energy, free energy.
Professor Ho-Baillie is now considered a world leader in solar panel technology. But with silicon solar cells fast approaching their theoretical efficiency limit of just 29%, she's focused on making the leap to the next generation of solar technology. Her team is layering metal halide perovskite and silicon to produce multi-junction or stacked solar cells. They're much more efficient than traditional cells because the different materials are better at absorbing different wavelengths of incoming sunlight.
With double junction solar cell, the highest efficiency we can get is around 40%, and for triple junction is around 50%.
Perovskite is a crystalline mixture of salt solutions that is light flexible, semi-transparent, and cheap.
At the moment, multi-junction cells are used in space, but they are based on gallium arsenide, and they're $10,000 per square meter. And they're very, very expensive. And metal halide perovskite is potentially at least 10 to 100 times cheaper than the current technology.
That means they offer enormous potential to power satellites at a much lower cost. But Professor Ho-Baillie hopes to one day see her multi-junction cells as a driving force to a net zero economy. She's already joined forces with a Sydney-based startup to commercialize the technology. It's the sort of forward thinking that has made her not only a highly cited researcher, but also a prominent figure at science outreach events. She has a passion for science education and for guiding the next generation of researchers.
There's a lot of hope with young people who are just incredibly smart, who go through this university, who are passionate, who are enthusiastic, and we are able to work on something that is directly impactful.
Her outstanding achievements have seen Professor Ho-Baillie awarded the prestigious Nancy Millis Medal from the Australian Academy of Science.